Hello, this afternoon we're going to balance chemical equations 13 and 14. Question 13 says, certain pollutants in the air react with water vapor to form acids. For example, sulfur trioxide reacts with water vapor to form sulfuric acid. So we have sulfur trioxide and water that form sulfuric acid. So if we think about sulfur trioxide, we know that tri means 3. So we're going to have SO3. And we know water is H2O. And that's reacting to form sulfuric acid. Sulfuric acid comes from your sulfate ion, and acid means that we have hydrogen. We know our sulfate ion is SO4 with a -2 charge. So how many hydrogens do we need to balance that out? Well, we need 2. So we're going to do H2SO4. So now we have sulfur trioxide, water forming H2SO4. So now let's look at whether it's balanced with the reactants and products. First we have sulfur, then we have our hydrogen, then we have our oxygen. If we look at sulfur, we have 1 on each side. If we look at our hydrogen, on this side we have 2. And on this side we have 2. If we look at our oxygen, on this side we have 3 and then 4. And if we look at this side, we also have 4. So this equation is balanced without changing any of the coefficients. Balanced. Without changing any of the coefficients. Let's look at example number 14. Here we have solid calcium carbonate is commonly used in antacids because it reacts with the hydrochloric acid in the stomach. The products of this reaction are aqueous calcium chloride, carbon dioxide, and water. So if we look at calcium carbonate, we know carbonate is CO3 with a -2 charge. And we know that calcium has a +2 charge. So if we're looking at calcium, which has a +2 charge, and carbonate, which has a -2 charge, our formula is Ca. CO3. And we're looking at hydrochloric acid. Now hydro, we think that comes from hydrogen, and chloric comes from your chloride ion. So we're taking a hydrogen and a chlorine together, and this is hydrochloric acid. And that produces calcium chloride. Now we know calcium has a +2 charge. And we know that chloride has a -1 charge. So we need to have 2 of the chloride ions to be able to make a chemical formula. So we're going to have that as CaCl2. And then we have carbon dioxide. Remember that di means 2. So we have CO2. And then we're adding water. Now we need to be able to count. Here we've got our calcium chloride, or calcium carbonate, and our hydrochloric acid. So if we look at our reactants and at our products, we have calcium, we have carbon, we have chlorine, we have hydrogen, we have oxygen. Remember, you want to have each atom separately. If I look at calcium, I have 1 calcium atom on that side, I have 1 on that side. Great, those are balanced. Now let's look at our carbons. Here we have 1 carbon, here we have 1 carbon and 1 carbon dioxide. Great, those are balanced. Now let's look at our chlorine. Here we have 1 on the reactant side, but we have 2 on our product side. So we need to change the coefficient in front of our hydrochloric acid to 2. So now our chlorines are balanced. Now if we look at our hydrogens, here we have 2 hydrogens. And over here in our water we also have 2 hydrogens. So those are balanced. That's good. And now let's look at our oxygens. Let's see if those are balanced. If we look here, we have 3 oxygen. And here we have 2 oxygen plus 1 oxygen, which gives us 3. So we have balanced our chemical equation simply by putting 2 in front of the hydrochloric acid. So we have 1 calcium carbonate plus 2 hydrochloric acid yields 1 calcium chloride plus carbon dioxide plus water. So that is questions 13 and 14 from today's lab. Have a great day. Bye-bye.